Welcome everybody to another episode of vBrownBag. We are doing the VCAP-DCV Design Objective 2.3 with Rebecca Fitzhugh today. Rebecca, if you want to introduce yourself.
I'm an Olympic gymnast and an aspiring actress. You can find me on Twitter at Rebecca Fitzhugh, and I do this VMware stuff, as a side job right now.
So Rebecca's VCDX. What's your number, by the way?
243.
243. And she's also vBrownBag crew, so we're really happy to have her recording. So just some things to get out of the way. You can get it on the conversation. Those are our Twitter handles, but we mostly monitor the hashtag vBrownBag Twitter hashtag, so you can send any questions there or through the interface of the GoToWebinar. And if you raise your hand, I'll open your microphone so you can ask Rebecca directly. With that, I'm going to send over control to her so she can start presenting, and I'll mute myself.
Okay. Breaking things. Okay. So, as Ariel mentioned, I am presenting on the VCAP-DCV Design Objective 2.3, in which we're talking about how you can build availability requirements into a vSphere 6 logical design. Now with this one, this is actually kind of a long objective. Okay, so these are all of the sub-objectives that we're going to be covering. So I'm not going to spend a lot of time here talking about each one because we're going to dive into each one separately. Okay, but we do have quite a bit to cover in this time period. So I'm going to go ahead and pre-apologize with this kind of breadth of material. Normally I like to give a lot of examples and a lot of designs, but because we have so much to cover and we don't have 6 hours to do so, it's going to be a lot of text. It's going to be a lot of bullet points, right, to make sure that I cover everything adequately. So I'd like to go ahead and apologize up front for that. So I showed this slide actually the last time I presented on a vSphere 6 VCAP topic. I previously talked about the conceptual model and objective 1.3, so you might have seen this slide before. So as a part of the design process, the first thing that we have to do is really assess, and we need to start gathering requirements, and then we need to start designing a solution that meets those requirements. Okay, so we're still in these two phases where we're going to be talking about how do we gather this information, what information do we need to gather, and then talking about how we can create that solution to meet those requirements. Now, I didn't show this slide before, but I do got to take a second here to talk about it a little bit. So this is design methodology. Okay, now specifically, this is my methodology, right? And it kind of fits the VCDX flow in the VMware kind of flow as well for your VCAPs. So the first thing is building out that conceptual model, right? So that's going to be you identifying requirements, functional and non-functional, as well as you identifying any kind of constraints. Now, as you go through, you might ask questions, you might not get the best answers, and you might make some assumptions, okay? Now, risks, unless it's something immediate out at the gate, something like we only have a single site, you may not start with any risks. Okay. But as you start making your design decisions and as you start building out that logical model, right, and logical design, you're going to make design decisions. And with those design decisions, those are not going to be just based on availability like what we're talking about today, but also things like recoverability, manageability, and so on. And you might take some risks. Okay. So as you take risks because of reasons like, for example, cost, you then go back to your conceptual model and add to it, right? So now I've taken this risk, how am I going to mitigate this risk? Okay, because there is no perfect design. Same thing as you move into physical, right? So I'm specifically buying this, or I'm specifically going to configure it X, Y, and Z way. You're going to make design decisions, and those are going to map back to your logical, as well as map back to your conceptual. Did you meet that business requirement? Yes, no. Did you introduce a risk? Yes, no. Is it documented? Okay. Now to kind of jump into objective 2.3, so the first one is evaluate which logical availability services can be used with a given vSphere solution. Okay. So I mean, it specifically mentions vSphere, so we need to consider our infrastructure redundancy. So we have things like, for example, vSphere high availability, fault tolerance. Okay, we have the ability to nicotine. We need to consider things like storage multipathing, but then you also have things that fall into DCV, for example, like set recovery manager. How does that play into your design? Okay, but you can't just consider only the infrastructure, right? So not just networking, not just storage, not just the compute resources and hardware. You also need to consider the application. So is it possible for me to load balance this application? Is there native load balancing within this application? Can it be clustered? Okay, and so on. How do I introduce that extra level of availability to make that as available as possible? Okay, and if I can't make it as available as possible, is that a risk? Okay, can I make it highly recoverable instead of highly available? Okay, and that's something we're going to come back to in just a second. And kind of going along the same lines of the virtual machines, so not just talking about native load balancing or even using an external, a third-party load balancer and clustering. You also need to consider things for availability. Like, for example, should all of my virtual machines that are domain controllers, should they all be on the same ESXi host? But what about DRS? Right? Couldn't DRS potentially over time place all of those virtual machines on the same ESXi host? What about putting it on the same data store? Okay, that would introduce potentially a risk. Okay, so how do you mitigate that risk? Okay, how can I ensure, for example, that all of my virtual machines that are domain controllers aren't placed on the same host? Right, and that's where you could use, for example, things like DRS rules. Okay. The next section is differentiate infrastructure qualities related to availability. Okay, so as a quick refresher, what are my qualities? So the main 5 that we always bring up over and over and over again with vSphere design is availability, manageability, performance, recoverability, and security. Okay, but of course we know that there are far more considerations than just that. One of the major ones that we always go back to is something like cost. How much is it going to cost me? Right, that's potentially going to be a big factor here. Now, notice that I have 2 in red. Okay, I've highlighted these because it turns out you can't actually highlight text in PowerPoint. You either have to color the whole box or nothing at all. And so if somebody knows how to use PowerPoint better than me, please let me know how to highlight text. But availability and recoverability, these are inherently linked. If I can't make something highly available, how do I make it highly recoverable? Right? So we're going to dive into that a little bit. Now, it would be remiss of me to not give credit where credit is due. So I'd like to actually minimize my section for a second and bring up René's blog. Okay, so you might have heard of VCDX 133 or visited his site. He has a rather extensive set of VCDX deep dive, and quite a bit of these are not just relevant to VCDX, but just design as a whole, and specifically, even relatable to the VCAP design series. He has a fairly lengthy blog post that to me was very, very important in my journey as an architect that talks about how does recoverability impact availability, okay, and to an extent vice versa. And so it goes through, and he's got a couple of examples, and he talks about downtime, he talks about business impact analysis, what are we trying to protect against, how do we do this, right? So how does something like your backup schedule affect availability, right? Well, the question is how does it impact the SLA, okay? So quite a great one, quite a great blog post, and I will give you guys the link at the end, okay? But I'm going to refer back to this several times throughout this presentation. Okay? So I do want to make sure that I am quite upfront here, and I tell you this is an invaluable resource, okay? So these 2 are natively linked, and we're going to see that throughout the rest of this presentation. Okay? Availability and recoverability, right? They impact each other, and we need to identify how they impact each other. Okay? So the next one is describe the concept of redundancy and the risks associated with single points of failure. Unless you have an unlimited budget, cough, cough, United States government, you're going to potentially have a single point of failure, okay? And it may not be something that you can control, okay? So how do I mitigate that? So what if I don't have true redundancy, right? Because when we talk about availability, this isn't what happens when it fails in terms of how do I recover it, right? Because that's recoverability. Oh, I recover from backup, or oh, no problem, I have the configuration stored somewhere else. Okay, that's not what we're talking about here. The question is, how do I make it completely redundant? Right. So I mentioned, for example, having a NIC team, and you need to think about, like, okay, I have a virtual switch, I have multiple NICs. Now, do these network interfaces, are they on the same physical card or not? Right? Are they the same physical PCI device? Because if they are, then you're not truly redundant. Yes, you may have two uplinks, but you still have a single point of failure. Okay. So one of the ones, I would say was very common up until version 6.5 was Vcenter. And we put some weight on Vcenter. Now we know, of course, distributed switches and Vsphere high availability and so on will function without Vcenter being online, but we of course need Vcenter online to do the initial configuration. And there wasn't traditionally a way to make Vcenter truly redundant, right? So we had to rely on things like backups. Okay, we had to, consider things like exporting the configuration of our distributed switch. Okay, we of course know now in version 6.5 that we do have Vcenter HA. Okay, now I will kind of stop and warn you. As far as I know, the current version of the VCAP is on 6.0. Okay, so take that into account. What if I only have one router? Or what if I only have one HBA? Yes, I may have quote-unquote redundancy because I have multiple paths because it's dual port, but it's potentially still the same adapter. Okay, so one of the things that you need to do is identify that single point of failure. It's a risk. Now, what are you going to do to mitigate that risk? Okay, so, again, things like backup configurations, backup virtual machines, and so on. And you need to have some kind of recovery plan. So I'm going to give you an example of a recovery plan. This is a very, very busy slide, I know. Okay, so right here in the center, we have just a very high-level logical example, right, where we've got two production clusters. We have a management cluster, we've got a test cluster. Okay, we've got our storage nodes down below. We have our SAN switching, we have our core switching, but we have a single router. Okay, we have a single point of failure. What happens if that router were to go down? How do I mitigate that? Okay, so in this particular example, I went with, we're co-located. Okay, we're in a colo, and as a part of my contract and a part of my agreement with that colo, the data center staff is allowed to rip and replace the router. Okay, and so they can replace that router with one of their on-the-shelf routers, right? If they're a big colo, they're a big, potentially service provider, right? Depending on what their business model is, they probably have extra gear laying around that I don't have as maybe a small business. Okay, so I've now signed this agreement. They're doing monitoring. I'm doing monitoring. They have my explicit permission via contractual obligation to rip and replace that router, and they have access to the configuration of that router because we back up that configuration every single time we make a change on the router. Okay, every time we add a sub interface for a VLAN or whatever, back it up, make it available to the data center staff. Okay, so what do we do from there? Okay, the router fails, they rip and replace, they restore that configuration from backup. Next thing that we need to do, as well as they need to do, is validate connectivity. Is it back up, right? Is it working? Now, on the side of the small business, the next step would be, okay, well, we need to order a replacement. Okay, we need to start moving through that. Now, we potentially have our services back on as soon as that router is back up and running, right? But that's effectively a temp-loan router, but we've mitigated that risk. And so we might say, for example, it takes somewhere around 15 to 30 minutes to recover. So this is me prioritizing, in a way, recoverability over availability. Availability would be having multiple routers, right? In this case, I don't have that. I have a single point of failure. So now I'm considering recoverability over availability. And so then you need to do an impact analysis. What does this impact performance-wise? Does this impact availability? Yeah. I mean, if my router's down, then I'm not going to have any kind of connectivity from outside the data center, and I'm potentially going to have routing issues within the data center, right? Where, for example, a VM on one subnet can get to another VM in a different subnet. Okay. But with that router failing and then getting replaced, is my RPO met? In this case, I'm not losing any data because I'm recovering from a backup. And we haven't made any changes since that backup. Is my RTO being met? Yes or no? Right? So then that's where we're seeing that this is affecting availability, right? Because availability goes back to that SLA. Okay. So that was kind of a rather lengthy explanation, but this is, one of the very few examples I have for you today, so I wanted to spend some time on it.
No, what I see very important in that example is to the level of detail that any person that is trying to explain how they're mitigating each and every risk has to go to in analyzing it, right?
Right. I mean, that's the hard part, right, about being, in a way, kind of an architect, is anything and everything is sort of in your scope, right? And you need to have that attention to detail, right? I mean, and especially when it comes like the VCAPs, to be honest. That's one of those exams where if you're not paying attention to those subtle details, you're not going to fare so well, unfortunately. Okay? Now, you heard me drop this SLA thing. All right, so let's start covering that. So one of the things that we need to discuss is the class of nines methodology. Okay, so this is something that we commonly use to define what our SLA is, our service level agreement, right? Which, in hindsight, I probably shouldn't have done these in the exact order that VMware has them on the blueprint, because it would make more sense to talk about the SLA first, so I apologize. So our class of nines. Theoretically, you could have 1 9, but who is guaranteeing only 9% of availability? I'm 100% down with that, because and by the 100% down, I mean, we're not talking downtime here. I'm in for a 9% availability agreement because a single point of failure for days. I don't care. But we typically start at 2, right? So 99%, 99.9, 99.99, 99.999. Okay? So I just broke this down in terms of downtime per year, but you have like slacalculator.com. Okay? If you don't want to memorize more than just the yearly, but it can break it down per month, per week, per day. Okay? How much downtime is allowed within that period. So here I just did per year. So on kind of the easier side of things, we have 99% availability, and you may have less, right? 99% may be optimistic in some infrastructures. I've been in some very archaic, I won't drop names, government data centers, and if we have 3 days of downtime a year, that's a pretty good year. But on the complete opposite end of the scope, right, on 5 nines of downtime, or excuse me, of uptime, that means that you would only have approximately 5 minutes of downtime per year. So having a single point of failure there, probably not so much of an option. So you're going to invest a lot of money in assuring that there are no single points of failure, making sure you have multiple sites, making sure potentially multiple actives, right, across the sites. Looking at potentially synchronous replication and so on. Okay, so there's going to be a lot of money that goes into that. And of course, we've got varying degrees, right? About 52 minutes for 4 nines, a little bit more than 8.5 hours for 3 nines. Okay. Now, what are these really telling us? Okay, these are us establishing our service level agreement, okay, our SLA, which is the next topic. So we need to determine that availability component of SLAs and service level management processes. Okay. So what is an SLA? Let's start with that. So this is potentially some kind of contractual agreement, either from a service provider to its customers or within an organization, right, where the IT department is guaranteeing services to all the other business units, okay, that it serves. What does an SLA consist of? A lot. So I put like 8 things here on the board that typically an SLA consists of. This is, in many cases, a legally binding contractual agreement. Okay, but I highlighted 3 that we pretty much always have covered. Okay, some of these, some of you may not have SLAs that are quite this explicit. Okay, but the 3 kind of minimal things is we're going to look at the metric. Okay, what is our metric definition? How are we measuring this in terms of what tool? Okay, and then what is the period? So for example, I completed my VCDX a few months ago, and in my VCDX it was a little bit unique with the SLA in a couple of ways. But one of the ways that my SLA was unique was that it was measured per week and only Monday through Friday. Okay, now that, out of context, you're going, what? But in context, when you understand the business objective and the business case, that made perfect sense. Okay, so every 5 days we're measuring the SLA, and then it resets on the weekend and starts over Monday morning. Okay, For most people, it's going to be a year, but we need to ask that, okay, as an architect. Okay, great, you want no more than 5 minutes of uptime. What does that mean per day, per week, per month, per year? Okay, what is that period of time? Now, I took all of this information and I just distilled it. We basically have two main components. We've got the services element and the management element. So the service element is going to be the specifics here. What's included and what's specifically excluded. Okay. Now I'd like to stop for a second and say you can have more than one SLA. You can have an SLA for, say, production virtual machines versus management. You can have, if you're disorganized, you may have tier 1 applications, tier 2 applications, tier 3, and so on. And your tier 1 applications may, for example, have 5 nines of uptime. Your tier 2 applications may have 3 nines of uptime. And then your tier 3, for example, if that's the bottom tier, it may have no SLA. We don't guarantee anything because these are test dev type VMs. Okay. So if there's anything that is excluded, for example, I was recently reviewing a VCDX for somebody. And one of the things that I thought they did a good job on is they specifically said the SLA is X, but what is not included in this SLA is, for example, our monitoring solution, right? So, which I thought was a little bit interesting. I'm going to exclude the tool that's monitoring the uptime, but that was something that they made the clear distinction. Okay, so you definitely need to specify what is covered by the SLA, but more importantly, what's not covered by the SLA. Now, speaking of things that are not covered by the SLA, if there's any kind of condition of service, for example, maintenance, you need to establish that. When is the maintenance window and how long is the maintenance window? And you need to specifically say, during that time period, the SLA does not apply. Okay? And then, of course, who's responsible for what? What happens if there is a failure? Right? What happens if that SLA is potentially not met? There could be legal repercussions. There could be money, right? There could be some fun money issues there where we have to potentially pay because we didn't meet our SLA. And
in there, whenever you are the customer, you're always thinking exactly how am I going to make it hurt for you if you don't meet the SLA. So.
Yeah, absolutely. If I'm paying you X amount of money every month, for example, because you're a colo or you're a service provider, and you can't meet that, you better believe that I want my money back, and then some, right? And then on the management side of things, this is us defining things like the standard of measurement. How are we measuring this? What are we using to measure it? What time period? How do we report this? Okay. How do we report this SLA? What are the contents of that report? How often do we report it? Okay, and so like for example, one of the I wish I could remember that. I think it was called Pingdom. Was the name of the tool. I recently sat in the SolarWinds kind of seminar, and they had this tool called Pingdom, which you could configure to like monitor certain sites. One of the things that I thought was very interesting was I noticed that the websites on the page that they were showing us, they all said 99.999%, or even some said 100%. I'm going, how are you measuring that, right? Because you could use that potentially as a tool, going, look, my website's always up. I'm Google, right? And so one of the things is like, how is it measuring it, and what is the interval in which it's measuring it, right? So at that time, I think they had it set to like within a 24-hour span. I'm like, of course this is 100% 24-hour span. So that's one of those things that's very important, is how do I report it and how often do I report it, right? Because if I only have to report my uptime every day, I shouldn't say that. If I only have to report it, how do I word this? If I am reporting it every day, that's probably in some cases to my advantage, because it's going to look higher than what it may be over, say, a 5-year span, right?
And that's a great point, because I remember a particular time when the SLA didn't address latency, for example. So pings would be responding all the time, but there was latency going up and down, and in those cases, that 100% may not mean that the customer is happy.
Yeah, exactly, right? And so that goes back into really detailing what's in scope for your SLA. And then the other thing too is, how do you update this agreement, and how often do you update this agreement? Because businesses change, and they what do they say? What's the Silicon Valley term? We're pivoting, right? We're going to pivot to a new direction. So if you pivot and you're pursuing something new as a company, how is the SLA affected by that? Okay, do you think when Google first started, their SLA was what it is today? Right? Same thing. Do you think when they had YouTube first start, which is of course owned by Google, but do you think that the SLA was what it probably is today? Probably not. Okay. Now, the next thing is create an availability plan, and to include your maintenance processes. Okay. So one of the first things that I would recommend doing, right, and you know, this isn't, I know I'm not the only person, because I was like, you know, making sure I'm on the right track as I'm putting this presentation together. So I looked at, you know, for example, Renee's blog. I looked at Greg Robertson's blog because they had some similar blog posts on this, and both of them said almost the exact same thing, where they said, you need to do a business impact analysis. Because at the end of the day, me saying, for example, that I need 5 nines of uptime, that's a completely arbitrary statement unless I can quantify it. Why do I need 5 nines of uptime? Let me put it another way. How much money is my business losing every minute or every hour that service is not available, right? So if you work, for example, for Progressive and your website's down, how much money are you losing from customers not being able to access, right, their insurance services, or not being able to sign up for insurance services, right? And your agent's not being able to connect to whatever application that they're using, okay? So we need to do that impact analysis because that helps us quantify and qualify why such SLAs are important. And that also helps us justify things like cost, right? Because again, if I have that 5 nines of uptime being required, that means I can tolerate no more than about 5 minutes of downtime a year. So that's going to be very expensive, right? That's going to be very expensive for me to have that level of consistency across my infrastructure. Now, one of the things that we need to do is get a little bit more precise than just specifying what is my SLA. Great, you've now said that my SLA is, you know, for example, I don't know, 4 nines, okay? Well, then we need to identify things like your RPO and your RTO. Those are the 2 big ones that we always go back to. So your RPO is your recovery point objective. This is how old can my data be, okay? In other words, if I have a failure and I have to recover, you know, either because of replication or because of a backup, I have to recover using one of these methods. How much data can I lose? Okay. And in some cases, you have people go, I can't lose any data. Okay, well then that already eliminates you using asynchronous replication, right? If I can't lose anything, then we already know that this is going to be quite an expensive process. Okay. RTO, this is your recovery time objective. This is how long effectively can the service be down. Okay, so how long do I have maximum to restore that service? And then you've got your WRT, this is your work recovery time. This is how long it takes that recovered service to be brought back up and available to customers. And this could be defined multiple times, right? You may have, for example, a generic RTO of, say, like an hour, but then your WRT may vary based off of what component we're talking about, okay? And then you have your MTD.
So just a question on the work recovery time and the planning that it takes. It could be that there's a run book saying this is what needs to be first, and we're going to test this at this point, and you have this. So total time might be an hour, but you have this intermediate steps that you want to hit, that you have to guarantee that you can hit, basically.
Absolutely. Absolutely. Right. So, I mean, and this could be, yeah, I mean, like you said, a whole site failure and how long, you know, what order each component should be brought up in and how long each component is going to take to recover. Or this might just be as, you know, granular as saying, okay, not if the whole site fails, but only if the router fails, or only if a core switch fails, or only if, you know, a NIC fails, or something like that, right? So, I mean, you could really, if you wanted to, you could really take this to the nth degree, right? And then you've got MTD. This is your maximum tolerable downtime. So this is basically your RTO plus your WRT, okay, and that equals your MTD. Now, and this is where, you know, I was trying to come up with examples of each of these, and I was going, why am I doing this? Because to be honest, when I have questions about this, I explain it to, for example, people who I've been mentoring for VCDX, and if they still don't get it, I go, read Renee's blog. Okay, read Renee's blog. Maybe I'm not doing a good job, explaining this, and then come back and let's talk about it again. Okay, so he has this lovely picture here. Talks about, hey, everything's great. Oh no, something happens. Right? So we have the RPO between that. How much data can I lose between everything is good to something bad happens? And then to my systems being recovered. Okay, now your system being recovered versus the actual service being available, those are two different things. Okay, yes, I recovered vCenter from backup, but how long does it take for that web client service to start? Right? Okay, because you might have met your RTO in theory by just recovering it from backup, and now it's powered on and now it's running. But if that service isn't available, and the users can't log in, for example, to the web. I don't know why I'm using vCenter as an example here. That's typically not a.
But let's put another example. Like you had this big outage, and in my case, I work with call centers. So even to the point that if you have a big outage, you send your agents on break to not bill them in those hours. So when you say system is back up, and you bring everybody back to the phones while they're signing in and this or that.
They better be able to actually log in. Right? Exactly. So that's a good example. I don't know what. I guess because I keep hearing Adam talking about vCenter today, that I was like, that's going to be my example for everything. And so we see, of course, that the WRT is measured between the time that systems are recovered to the time that things actually are resuming and working, and users are able to access that infrastructure. Okay. Now, in my kind of opinion, I guess I'll say opinion here, your RTO and your RPO should not exceed your allowable downtime as dictated by your SLA. Okay, and this is something that I see a lot in terms of the VCDX, which I know is kind of out of scope for the VCAP. Yeah, Ariel said it's important, right? Because I mean everything's building on, right? So it's like, generally speaking, I'm going to make a very broad assumption here, so let's document this as an assumption in the conceptual model. If you achieve both VCAPs within a realm, why? Right? I mean, likely you're probably going for VCDX at some point, right? Or you just really like taking exams. Ariel, I'm looking at you.
I'm totally tweeting this. Rebecca says if you have VCIX, you have to take the VCDX. Okay, you got it.
Well, yes and no, right? Now I've said a controversial statement, but I mean the reality is that unless you work for an organization that recognizes the value of VCAP, which is arguable of how many do or do not, then it's kind of like why go through that effort? Okay. So I mean one of the things I see all the time, for example, is I will have somebody say in their VCDX design that I'm reviewing that we're going to have an SLA of, for example, let's go to our lovely uptime calculator. Let's say they say I'm going to have 4 nines of uptime. Okay, so 4 nines of uptime. So that means I can tolerate no more than 52.6 minutes a year. But then I will look at their RTO and their RPO. And their RTO, for example, might be 60 minutes. It's 1 hour. You're already violating your SLA. Same thing with your RPO. Okay. If you say, hey, yeah, I'm going to, for example, replicate every 2 hours, you're violating your SLA. And so, because you have to think, great, you might be able to recover your database, from backup, or you might have like a replicated data store somewhere else. But if your user logs in, right, and they're now logging in and looking at their, Outlook, if that Exchange server just lost 2 hours of emails, are you really meeting your SLA? Right, same thing. If you just lost 2 hours worth of data in a database, are you really meeting that SLA? And I'm going to argue here, no. Right, but again, I guess it really does depend on the scope of the SLA. Okay, so Renee has some great examples. I was coming up with examples, and I was like, where did these examples come from? Like, I was like, I recognize these examples, and I realized, like, oh, I've read this blog post so many times that these are not even my own ideas anymore. Right, where is it? So right here, for example. So he gives you some examples of, okay, well, if you have, for example, 2 nines, what could your, right, so this is a big thing here. This does not mean it has to look exactly like this, but what could it look like? Okay, so 2 nines, maybe an RPO of 24 hours, an RTO of 24 hours, WRT of 12, right? That gives you a total of 36. And if we come back up here to our SLA definition, 36 hours, that still falls well within the over 3 days. Okay, so that even gives us a safety net built in. Now the hard one is 5 nines. Okay, your RPO may be 5 minutes. Okay, but you only have 5 minutes and 5.26 minutes. Okay, so we're already cutting it a bit close there.
Yeah, I always heard that 5 nines, you can't even boot all VMs and have them communicate properly.
I'm not going to argue that point, but yeah. So, I mean, here you could even argue that your RPO should be 0, right? But it really goes back to the business itself. Okay? So this kind of gives you an example of some RTOs, RPOs, and then the WRT, along with adding that WRT to your RTO and giving you your MTD. Right? So I just said a bunch of acronyms really quickly. So I know we all totally get it now, right? Now, once you've done that business impact analysis and you've established things like your RTO and your RPO, then what? Okay, so Ariel brought up a run book. Manual or automated? Okay, how am I going to protect my site? Well, let's go with this. How relaxed is my SLA? Because if my SLA is 50%, do I really need 2 sites? Right? But if my SLA is 5 nines, I probably need another site, right? I probably need a secondary site. So I need a DR site. How am I going to do failover? Am I going to use stretched clusters? Right? So with that, you're looking at potentially synchronous replication, and you've got a distance limitation, right, of 100 kilometers, okay, for stretched clusters. Or do I want to use Site Recovery Manager? Okay, or do I want to have, for example, 2 physical sites that are both active and we're load balancing across sites? Right? I can do that as well. How often am I backing up my virtual machines? Right? Because again, this is going to play into your, for example, RPO. Are your backups going to be application consistent? What about vSphere HA? How should that be configured? Okay, because if your SLA is 99 let's just go 99%, probably n+1 is more than sufficient. Okay, but if you have, for example, 5 nines for your SLA, yeah, probably going to be looking at n+2, I'd say, at a minimum, right? So that's going to change the way that you configure vSphere high availability. For this application, does it qualify for fault tolerance, right? For vSphere fault tolerance. We already mentioned things like application load balancing, application clustering, okay, and so on. Replication, right? This goes back to my RPO as well. Synchronous or asynchronous. Okay, and then of course, when does the SLA not apply? What time periods are excluded? So this is usually something like maintenance. Now, I don't know why I didn't hit play. There we go. Now we can probably see it. And so the big thing here, the last kind of point on the slide says test and validate. Okay, all of this documentation, all of these decisions, all of this work is effectively worthless if you haven't tested it and made sure it actually works. What is the point of having a run book if you haven't tested that run book is actually going to be effective? Okay, so you really need to test, you really need to validate that these things work and you are able to recover that data and that service within that time period. Okay, now I'm going to pause for a second, and again, I shout out to Renee, because there's really nothing that I could create. I tried to create some stuff, and I was like, man, none of this is as effective. It's just showing you what's already there, what's an amazing example. So this is kind of a more holistic sort of approach, right? So he shows you a couple of things. We're like, okay, we have an established SLA of 99.99%. So give us about 53 minutes of downtime that's unplanned each year. Okay, we've established a maintenance window. Okay, from doing our business impact analysis for tier 1, specifically here tier 1 services. So again, I may have multiple tiers, and I've now established multiple RPOs and multiple RTOs. Okay, but specifically here for tier 1, we've established these RTOs and RPOs. Okay, what are we protecting ourselves against? Because that's another thing. Some of the things that may apply to, for example, an insurance organization may not apply to you if you work in, say, healthcare. right, and vice versa. So what is the threat? What is the potential issue? I lived in New Orleans for over a decade. One of the things that we want to protect against is a hurricane, right? And so one of the things that you would consider here is like, where's my DR site going to be? Houston is probably not a great example of a DR site, which, unsurprisingly or surprisingly, during hurricanes, Katrina, Gustav, Ike, you had businesses who did have, right, their DR site in Houston, which didn't bode well during the Katrina timeframe because right after Katrina there was Rita that came right into the Houston area, right? So what type of disaster am I trying to protect myself against? What is my backup schedule? Right. So notice here, it says, for example, like every 10 minutes. Why goes back to the RPO here? Okay, goes back to the RPO. And how long does it take to recover? Great, I'm glad I have that backup. But how quickly can I recover from backup? Okay. So, and then of course he has kind of a high-level logical diagram where he's got things like load balancers, right, DNS, right. So of course redundancy for databases, web servers, and so on. Okay. So this is kind of a very high-level example, right? But this does give you an example of the types of things that you need to be thinking about and looking for. And then of course, again, I will stress test and validate. Okay. Now, I think this is our second to last bullet point, is going to be balance availability requirements with other infrastructure qualities. Okay, so this goes back to, again, looking at ampers or ramps or parms or however you want to call it. Right, so availability, recoverability, performance, manageability, and security. You might go, yes, look at all these design decisions I've made. I've got redundancy here, I've got redundancy here, I've been doing load balancing here, then I'm also doing replication here, and I'm clustering this. But the thing that you have to consider is, great, I'm glad you made all those decisions, but how does that affect the manageability of that infrastructure? Now let's say that you do have a complete site failure and you have to recover your site. And let's say that you made this horrible decision of doing a manual runbook. Okay. I'm saying horrible only because that's a lot of work to manually recover.
And also when you say manual versus automated, you're going to have to time someone and say that person is available whenever there's an outage. So it involves a level of risk and uncertainty. So totally get it, yeah.
Yeah, but I mean, like, that's what we're actually doing next is I'm going to time Ariel with a stopwatch and have him run through a manual runbook and see how quickly he can recover an infrastructure. So we're practicing for the IT Olympics. But that's going to affect your manageability. So you have to kind of weigh the pros and cons here. What's more important, availability or manageability? And there's things that you have to consider here. What's the skill set of your staff? Right? Can they do a manual recovery? Do they have that capability? And not just using ramps, but again, I want to bring up money. If you're going to be providing 5 nines of availability, that's some serious dough. Can you afford to do that? Right? That's one of the fun VCDX challenges that you might see in the design scenario where they go, we want 5 nines and you have a budget of 0. Go. And you're like, right? But, you've got to consider things like replication. Again, active sites, the skill set of the staff. I want to go back to skill set of the staff. And that's going to play back into, guess what? Did you test and validate that this will actually work? And because human error is real. Okay? And then the last one, and this is honestly far and away the easiest bullet point here, and that is analyze a vSphere design and determine a potential single point of failure. Okay, and I don't have any additional information here. That's one of those things where, can you identify? For one of the examples that I gave earlier, I said you may have a virtual switch that has multiple uplinks. But those uplinks may be coming from the same PCI device. Okay, you need to identify that as a single point of failure. And I can't tell you how many times I've used that example. Teaching VMware classes, I've had people go, oh, like they just never thought of that, right? I mean, once you hear it, you go, oh, of course, duh. But when you're looking at your vSphere infrastructure, you go, great, 2 uplinks, no problem, right? But there's more to it. Same thing, great, I've got more than one, for example, path to storage, but I only have one HBA. There we go, single point of failure. So it's you now taking all of these ideas, because this is a whole lot of, even though we're talking about a logical design, right? So you making the design decision of synchronous versus asynchronous, right? That's a logical design decision. And then your physical design decision is what storage array is capable of doing that and which one meets all of my requirements. And then choosing, for example, dplex. Okay, that's a physical design decision. But it's you now being able to take all of these ideas and analyze an infrastructure and determine what is a single point of failure. Okay, so here is the link that I've referenced several times now of Renee's absolutely thorough and the most applicable kind of blog post I've read in terms of availability. Okay, so here's our lovely link, and I know that we're kind of coming close on time. I think we've got about 10 minutes. I know I talked very quickly here through a lot of material, but I do want to go ahead and open it up for questions.
All right, I will open up the microphones for everybody that wants to do a live question. And please do so. Just know that you are the thing that is holding us holding us going back to the room with the beer. So.
I don't know what Ariel's talking about. I'm drinking a beer right now.
All right. Well, first of all, thank you so much. And we always ask the presenters to make a blog post, so you'll find either a slide share or at least a blog post with that link for Renee's blog. I didn't get any questions, Rebs, either on Twitter, nor I do see anyone raising their hand or asking a question. But I'm going to put someone on the spot. Alex, who is right here with us, is a live attendee for our vBrownBag recording. Alex, do you have any question for Rebecca from all the things you saw?
I would say, coming from the customer side, so and you've been on the consulting side. I'm just curious, when you've done this type of consulting work, what's the most realistic SLA that you've seen customers ask to you?
Great question. So I mean, absolutely any SLA is realistic with the right budget skill set. Okay. Now that being said, you will sometimes get a customer who is a small business who's single site, and they go, "I want to have 5 nines of uptime." And immediately, you just, of course, politely, you don't roll your eyes or laugh, though inside you do, and you kind of do it once you leave the room. But you're going, "How can I ever guarantee no more than 5 minutes of downtime in a year if you only have a single site?" Right? And so then I would say that's a very example, an example of a very unrealistic kind of SLA. So then at that point I'm going, yeah, you need to be looking at more like 99%, right? Because that gives you a little over 3 days. Worst case scenario, disaster strikes, you lose your single site, you could potentially go colo, and if you have backups that are offsite, if you have all these things that you've considered, then you could potentially recover your infrastructure in 3 days. Right, rather than saying 5 minutes, right? That's an example of an unrealistic one, right? But I mean, you work for a very large, so you work for a customer, right? But you work for a very, very large customer. So your enterprise organization, do you have an established SLA?
It varies by application, and they're tiered.
Yeah. And that's perfect, right? One size does not always fit all, right? So you do have organizations that go, all right, SLA is X. And that goes back to defining the scope. What does that cover? Does that only cover tier 1 apps? Does that cover everything? Is that only the infrastructure? What is that covering? Because that may not be realistic. And because, like, for example, you work for a very large enterprise customer, you may not be able to guarantee a certain SLA for every unit within your company. Right? You might have, for example, finance and HR as 2 separate units within, and you're guaranteeing them potentially separate SLAs based off of their application workload and what's specific to that particular division, right? And that's okay. Don't let them find out because you don't want that political battle, but it's okay to have multiple SLAs. But yeah, I would say keep it realistic, right? You can't say single site. And then I would say that's a constraint if we're going to tie it back to Objective 1.3. That is a constraint, single site, and also a risk, right? And how do you mitigate that risk, right? So that goes back to like offsite backups, blah, blah, blah. But you having 5 nines in a single site, that's not very realistic. And I would push back very hard as a consultant coming in?
That's a great question. Thank you so much, Alex. And for that particular customer, I would ask him, okay, a plane fell down, malfunction, ran out of fuel on your data center. This is disaster recovery, and you're asking me to give you a 5-minute one with only one site? That's impossible, right?
Just examples of plane falling out of the sky and hitting your data center. Did you watch Breaking Bad recently?
But see, I've actually had this is a sad story actually, but I know people, that would like do-it-yourself planes, and they the success factor is not 100% on those. They fall down wherever they fall down. So.
Or if you're, Harrison Ford near the pilot. You're going to land in golf courses, not taxiways instead of runways. Just kidding, Harrison. Call me later.
All right, with that, we'll start the recording. Thank you, everybody that attended live, and you know where to find Rebecca. Thank you so much for attending. Bye-bye.